Hello, this is Keith Graham from Codasip. I'd like to introduce you to either your Comp Org or Computer Architecture Assignment 5. It's all about data path and instruction decoding. Throughout this assignment, you will be using two new projects. One project that you're going to have to import is this add-I assembly test. Now, this test will be used by you to validate the ITYPE, the immediate type data path through an add-I immediate operation, as well as the RTYPE data path through the add operation. There's the second file that you will be using for this assignment is the RISC-V32i cycle accurate. This is your new processor project for this assignment as well as moving forward. This is your template to enter or to create a cycle accurate RISC-V design. Now, if we expand models, then expand CA for cycle accurate, you're going to see some folders that you have not interacted with before. The first one is the decoders. In this particular file, CA, all the files that are related to the cycle accurate model start with CA. It's just a nomenclature that we know this is cycle accurate. Now, if I scroll down here, you can see that for each instruction type, the decoder will set certain signals that will be used through the different stages of your pipeline to tell that pipeline stage what to do. For example, we have reg write, which signifies when this instruction moves from the decode all the way through the write to the write back stage, that if that is asserted or true, the result will be written to the register file. We also have, like as an example, ALU op. So ALU op right here is a microarchitecture opcode, which will be used by the execute stage to tell the ALU what type of operation to perform. An add, a AND operation, exclusive OR, for example. Now, if we scroll down in the CA model, we also have this pipeline folder. And within the pipeline folder, there are 6 files. The first one is control. And the control.codal file, actually, you won't do anything with that in this assignment, but later assignments you will use that to stall the processor as well as insert no-op bubbles. The other 5 files are actually the implementation of the different stages of the 5-stage pipeline through instruction fetch, instruction decode, execute, memory, and write back. So you will be modifying these files to actually implement the data path for both the ITYPE and the RTYPE files or instructions. Now, the last key file that you're going to be doing a lot of input or work with is under the resources, CA resources. This particular folder, actually, you will define or declare the global or the system resources for signals, which are just wires between logical elements, as well as registers, which are elements that are sequential. They're called sequential elements, and they will clock in the data on a rising edge of the processor clock, then output the new data after the clock edge. It stores data. A sequential element, it stores data. You'll also be declaring a special type of register, which is a pipeline register. A pipeline register in our model, in our language, actually has 2 additional inputs. One for clock enable, which enables you to stall a pipeline, or clear, which you use to insert a no-op bubble. Both of those, once again, will not be done in this particular assignment, and you control both of those signals through the pipeline control file under the pipeline folder. So this assignment, I just will let you know, is more difficult than the previous ones because you're entering a new part of the design, which is actually implementing the 5-stage pipeline. Hopefully everything goes well, and good luck.